Hi, now we will see about polynomials. There are 13 chapters, we will go one by one. Now we will see chapter 1. Polynomial is a function written as a0 plus a1x plus a2x squared going on up to an x power n. N is the highest power. Term is any one piece in this sum. ai x power I, where I is an element of whole number, that is 0, 1, 2 or any natural number. Leading term is the term containing the highest power of the variable. X power n is highest power of variable here. Therefore, an x power n is the leading term. Leading coefficient, the coefficient of the leading term here. An is the leading coefficient. Degree, highest power of the variable that occurs in the polynomial. That is called degree of the polynomial. So what is the degree of the polynomial here? N. Because that is highest power. Coefficient, each of the ai constants is called coefficient. Each individual term ai x power I is a transformed power function. Each term is a power function. Right? What is power function? We will see. F of x is equal to x power p is a power function where the base is the variable x, very important, and the exponent p is a number, a constant. Is 2 power x a power function? No, because here the base is not variable, the power is the variable here. This function has a constant base raised to a variable power. Therefore, this is called an exponential function and not a power function. Coefficients can be positive, negative, 0, whole numbers, decimals or fractions. Anything, any real number. A is an element of real number. I is an element of whole number. Short-run behavior of a polynomial. How the polynomial behaves in a graph. Characteristics of the graph, vertical and horizontal intercepts should be known here. Places where the graph changes its direction, we must be able to find out. Vertical intercept is where the graph crosses a vertical axis. So what do you mean by vertical intercept? It is the point where the graph crosses the y-axis. Vertical intercept is the output value where the input value is 0. Because x value is the input value, at x is equal to 0, find out the y value, that is the vertical intercept. And it has to be unique because polynomial is a function. Vertical intercept is unique since polynomial is a function. Horizontal intercepts is the input values where the output value is 0. Output value can be unique 0 for many inputs because many to one function. Horizontal intercepts can be more than one. Horizontal intercepts are called zeros or roots of the polynomial function. Long run behavior of a polynomial. What is long run? It's called stretching. Long run behavior of any polynomial will match the long run behavior of its leading term. The coefficient of the leading term a is called the stretching constant. See here, the stretching is upwards, stretching is downwards. Here one side stretching upwards, another side stretching down, left to right. Here right to left. One side, right side stretching upwards, left side stretching downwards. So it all depends upon the coefficient of the leading term, that is a, and the odd or even power of the degree. Then we will see the degree of the polynomial. Polynomial is a function written as a0 plus a1x plus a2x squared going on up to an x power n. Polynomials are arranged in the descending order of powers, not like this. It is an ascending order. So we will change it to the descending order. Definition of leading term is therefore in order with this arrangement. That is, if I arrange it in the descending order, x power n term will come first, and that is the leading term, rightly so. So f of x is rewritten as a0 into x power n plus a1 x power n minus 1 plus a2 x power n minus 2 going on up to a n minus 1 x power 1 plus a n x power n minus n is 0, x power 0 is 1, therefore plus a n. The constant term from the first goes to the last. And this is the leading term. So degree is the highest power of the variable that occurs in the polynomial. That means x power n. So n is the degree because x power n comes first and all the other terms are having less than this degree, less than this power. Which of the following are polynomial functions? F of x is equal to 2x cubed plus 3x minus 4. Yes, degree 3. X into x squared minus 4. This is again polynomial of degree 3. 5 root x plus 2, no it is not, because root x is not allowed. F of x is equal to 2x cube plus 3x minus 3 by x, no it is not a polynomial, x cannot be in the denominator. Division by x is not allowed. 5x squared plus log x is not allowed. Log x squared plus log x is not allowed, because log x is not allowed. E power x squared minus 4, see this is also not allowed because e power x is not allowed. We will see algebra of polynomials, addition and subtraction. Addition. Add the coefficients of the like terms, that is power should be equal. F of x is equal to 9x power 4 plus 6x cube plus 18x squared plus 2x minus 6. Another function gx is 7x power 4 plus 4x cube minus 20x squared minus 5x plus 7. So what is the like terms? X power 4 like terms, so that you have to add 9 and 7. Similarly here x cube coefficient 6 and 4 we have to add. X squared coefficient 18 and minus 20 you add. X coefficient 2 and minus 5 add. And constant term minus 6 and plus 7 you add. So 9 plus 7 is 16x power 4, 6 plus 4 is 10x cube, minus 2x squared, because plus 18 minus 20 is minus 2, plus 2 minus 5 is minus 3x, minus 6 plus 7 is plus 1, therefore 16x power 4 plus 10x cube minus 2x squared minus 3x plus 1. That is what we say, add the coefficients of the like terms, which is more convenient and easy for following. Now we will see subtraction. Now instead of doing subtraction, adding the opposite is more easier. How do we get the opposite terms? It is easy. See here, step 1, keep the first polynomial the same. Change the minus sign to plus. Now change all the signs in the second polynomial. Blindly. Change every sign in the second polynomial. Now keep adding. Add now. You know how to add. Like terms you add. See, fx is 9x power 4 plus 6x cube plus 18x squared minus 2x minus 6. Gx is 7x power 4 minus 4x cube plus 20x squared minus 5x plus 7. So f of x minus g of x is, I retain the first term and then minus, and then second polynomial is this. I just have to change this minus sign to plus and then change the coefficients to minus opposite sign throughout. So plus 7 is minus 7, minus 4 is plus 4, plus 20 is minus 20, minus 5 is plus 5 and plus 7 is minus 7. Now simply add the like terms. So 9 minus 7. So I am adding minus 7 to 9 means 9 minus 7 is 2. So if you do it, 2x power 4 plus 10x cube minus 2x squared plus 3x minus 13 will be the answer. Now do it here. So I have just taken the like terms, x cube plus 6 here and plus 4 here. X squared plus 18 minus 20. X minus 2 plus 5. And then constant term minus 6 minus 7. Because I don't have to bother about this because this is always plus now. Now the answer is 2x power 4 plus 10x cube minus 2x squared plus 3x minus 13. We will see one more problem. Evaluate the following. 5f minus 3 minus 4 minus 2f minus 9f plus 6. So all you do is change the minus sign, change the sign of 4 and minus 2f. So minus 4 plus 2f, change the minus to plus, change the minus 9f to plus 9f, plus 6 to minus 6. Now keep adding it. So 5 plus 2 plus 9, 16, and minus 3 plus 4 plus 6, sorry, minus of, say I have taken minus sign outside because minus 3, minus 4, minus 6, therefore minus 3, minus 4, minus 6 is minus 13, and 16f minus 13 is the answer. One more problem, 8y cube minus y squared minus 4 plus 4y squared minus 6 minus y cube minus 2y. Here there is a plus term, so we don't have to do anything. Here there is a minus term, change it to plus and change the terms inside opposite sign. So y cube is minus y cube, minus 2y is plus 2y. Now you add. So y cube into 8 minus 1 plus y squared into minus 1 plus 4 and plus 2y. Where is 2y is there here? There is no other 2y. Minus 4 minus 6. So now you keep adding it. 7y cube plus 3y squared plus 2y minus 10. That is the answer. Now we will see algebra of polynomials, multiplication and division. Step 1, multiply each term in one polynomial by each term in the other polynomial using distributive law. Do you know what is distributive law? A into b plus c is equal to ab plus ac. Step 2, add the powers of the same variables using the exponent rule. What do you mean by exponent rule? X cube means x cube term you should add. All the x cube coefficients you should add. All the x squared coefficients you should add. Step 3, simplify the result by adding or subtracting like terms. We will see an example. X squared plus 1 into x cubed plus 2x plus 4. So I take x squared and multiply by each term, and then I take plus 1, multiply by each term. Therefore it remains as it is. So x squared into x cubed is x power 5, x squared into 2x is 2x cubed, x squared into 4 is 4x squared, plus x cubed plus 2x plus 4. Now you add the like terms. X power 5, there is no term to add. X cubed, we have two coefficients, 2 and 1, so 3x cubed, plus 4x squared, plus 2x plus 4, because there is no like terms here to add. Now we will see a algebra of polynomials of division. So dividend is equal to divisor into quotient plus remainder. So you should know what is dividend, that is a number to be divided, and divisor is number which is dividing, quotient is the value which you obtain by after division, and remainder is after dividing then we get the remainder. So remainder should be greater than 0 and less than divisor. This is very, very important. It is a positive number, not a negative number. 176 is equal to 3 into 58 plus 2. So 176 is the dividend, 3 is the divisor, and 58 is the quotient, and 2 is the remainder. If you divide by 58, then 58 will be the divisor, then 3 will be the quotient. So this is 174 plus 2, that is 176 tallying. Please see here, it checks here. 2 is less than 3, right? 0 is less than 2 and 2 is less than 3. So divisor is 3 and remainder is less than divisor 3. Now remainder should be greater than or equal to 0. I told you. We will see one more example. 51 divided by 8 is 8 into 6 plus 3. So 8 is the divisor, 6 is the quotient, 3 is less than 8 and positive. Now suppose I take minus 51 divided by 8. Then I should not take 8 into minus 6. 8 into minus 7 plus 5. Therefore divisor is 8 and remainder is 5 less than 8 and greater than 0. Right? Minus 51 minus of minus 56 is plus 5. Therefore 5 is the remainder and minus 7 is the quotient. Clock A works in mod 12. What will a 12-hour clock display 7 hours after 9? That means we will have to find out the 7 plus 9, 16 mod 12. Right? So 7 hours after 9 means 9 plus 7 hours. And we have to find out the modulus by dividing by 12. So 9 plus 7 mod 12 is 16 mod 12, which is 4. The remainder is 4. 16 mod 12 means find out the remainder of 16 when divided by 12. Therefore, the clock will show 4 o'clock. We will see algebra of polynomials division. What is the algorithm here? Given a polynomial dividend fx, non-zero polynomial divisor dx, where degree of dx should be less than or equal to degree of fx, there exists unique polynomials qx and rx such that f of x is equal to dx qx plus rx. Qx is called quotient, rx is called remainder. Now we will see division algorithm. Algorithm is given a polynomial dividend fx, non-zero polynomial divisor dx, where degree of dx less than or equal to degree of fx, there exists unique polynomials qx and rx such that f of x is equal to dx into qx plus rx, where qx is the quotient, rx is the remainder. So rx should be greater than or equal to 0, less than dx. Case 1, there will be only one case. We will see that rx is equal to 0. That means dx is evenly divides into f of x. Rx is equal to 0 means dx evenly divides into f of x. Both dx and qx are factors. Otherwise, Rx is not equal to 0 means Qx is not a factor of f of x. Okay. So remainder should be 0 for dx to be a factor. If Rx is not equal to 0, then Qx is not a factor of f of x. Now we will do a problem. Divide 2x cubed minus 3x squared minus 4x plus 5 by x minus 1. So first write this polynomial and then write a box. Put that x minus 1 outside. Now multiply this by a number so that this gets cancelled. So 2x, if I multiply 2x into x is, no, 2x squared into x will give you 2x cubed. Therefore I put 2x squared and then multiply this. 2x squared into x is 2x cubed. 2x squared into minus 1 is minus 2x squared. Now I subtract, then this will be 0, this will be minus x squared, and then minus 4x, I will bring it here. Then I will have to make this as 0, a minus x squared. Therefore what I will do is what I will do is I will multiply by minus x into x is minus x squared, and then minus x into minus 1 is plus x. Now subtract, this will become 0, and this will be minus 4x minus of x is minus 5x, and then take this 5 here, and now you will have to multiply by minus 5, so that minus 5 into x will be minus 5x, and minus 5 into minus 1 is plus 5. So now if you subtract, you will get 0. Therefore the factor is 2x squared minus x minus 5. Therefore 2x cubed minus 3x squared minus 4x plus 5 by x minus 1 gives you 2x squared minus x minus 5. Long division, we will do one more problem. Divide 5x squared plus 3x minus 2 by x plus 1. So I have done it. 5x squared plus 3x minus 2, x plus 1 is outside. I multiply by 5x first. 5x into x is 5x squared. 5x into 1 is 5x. So 3x minus 5x is minus 2x. Minus 2, I bring it down. So I multiply by minus 2 here. Minus 2 into x is minus 2x. Minus 2 into plus 1 is minus 2. The remainder is 0. Therefore 5x squared plus 3x minus 2 is equal to x plus 1 into 5x minus 2. So 5x minus 2 is the answer. Now we will see graphs of polynomials, identification and characterization. Polynomial functions of degree 2 or more have graphs that do not have sharp corners. They are smooth curves. Polynomial functions are continuous and therefore have no breaks. F of x is equal to x cube minus 0.01x. We will just plot it here. This is a continuous curve. And here this is having a break, therefore this is not a polynomial. Graphs of polynomials, identification, characterization, we will see more. Recognize characteristics of graphs of polynomial functions. That is what you should do. How do we do it? We will see. Factorize to find the zeros of your polynomial functions. We should know how to find out the zeros. These are all called x-intercepts. Identify zeros and their multiplicities. If you have multiplicity, then it will give you it is a linear behavior or quadratic behavior at those points. Determine the end behavior. This is called sketching, and sketching factor is the leading term coefficient A. Relationships between degree and turning points. We should know this. So n minus 1 turning points will be there. Maximum. Graph polynomial functions once you identify all these things. We will see all in a nutshell now. What is the domain for all polynomial functions? The domain for any polynomial is all real numbers. Right? R to R, real number to real number, y is equal to f of x such that x is an element of real number and y is a polynomial. Any real number is a valid input for polynomial function. We will see another problem. Revenue in rupees million from year 2017 to 2024 is shown here, 8 years. So year and data is given here. This can be modeled by a polynomial function. There are softwares available. So one such result is R at t, that is revenue at time t is equal to minus 0.037 t power 4 plus 1.414 t cube minus 19.777 t squared plus 118.696 t minus 205.332, where t is given by year minus 2000. So that t becomes a double digit number maximum. And you can substitute and get the revenue each year. We can get answers to many questions from this model, like in which interval the revenue is more or less or increases or decreases and things like that. Identify the polynomials. Here this is a polynomial, yes or no? Yes. This is not a polynomial because sharp corners are there, and here it is a polynomial, and here there is a break, therefore this is not a polynomial. We will see the answer. It's a polynomial, not a polynomial, polynomial and not a polynomial. Now we will see zeros of polynomial functions. At x is equal to minus 3, x is equal to plus 2 and x is equal to plus 4. Therefore, the relation is, function is x minus 2 into x minus 4 into x plus 3. Zeros are minus 3, plus 2 and plus 4. Therefore, x minus 2, x minus 4, x minus or minus 3 is x plus 3. If f of x is equal to x minus 2 into x minus 2 into x plus 3, then what happens? We will see. Zeros have multiplicities. Therefore, here multiplicity of 2 is 2. So zeros of polynomial functions. Use factoring to find zeros of polynomials. Use multiplicities to find the behavior of the polynomial. We will see what is that. So here is single zero. Here multiplicity is 2. Therefore quadratic behavior. Here again multiplicity is 3. Therefore it changes It is not linear, but sign changes. Here linear and sign changes. Here no sign change, quadratic. Here not linear, not quadratic, but sign changes. Now we will see graphs of polynomials, multiplicities. Multiplicity is the degree of each factor. Multiplicity is the amount of times a factor appears. X minus 2 whole square, that 2 appears 2 times. Depending upon the exponent, the graph crosses through or bounces off the x-axis. Right? Depending upon the exponent value, odd or even, the graph crosses through or bounces off the axis. If the exponent is odd, the graph crosses through the axis. If the exponent is even, the graph bounces off the axis. That means quadratic behavior. Here cross means linear behavior. We will see more on this. Y is equal to P1x is equal to x minus 1 into x minus 2 into x minus 3. Therefore no multiplicity here. Another function we will see. So P1 is known here. 3 zeros are there. 1, 2 and 3 values. Here P2x is x minus 1 into x minus 3 into x minus 3. Therefore multiplicity of 0 is 3 here at 3. Therefore when x is less than 3 or greater than 3, x minus 3 into x minus 3 is positive. Right? Therefore quadratic behavior. The P2x is see minus 3 or plus 3, this is always positive. So 0 says 1 multiplicity is 1, 2 multiplicity is 1, 3 multiplicity is 1 for the function P1x. For the function P2x, it is for 1 it is 1, for 3 it is 2. And therefore P2 is behaving like this. Because multiplicity is even here, quadratic behavior. Multiplicity is 1 here, so the linear behavior. Now you will be able to see the difference in characteristics of P1x and P2x. Right? If multiplicity is odd, sign changes. If multiplicity is even, sign remains the same. Sign does not change. Number of zeros is less than or equal to degree of the polynomial. Please, number of zeros is equal to degree of polynomial, or at the most equal to degree of polynomial. If there is a multiplicity, it will be less. How many distinct zeros the polynomial has? Right? If you add all the multiplicities, you get the degree of polynomial. So here for P2x, here the multiplicity is 2, here the multiplicity is 1. So add 1 and 2, 3. So the degree is 3. Yes or no? For P2x, the degree is 3. X into x into x is x cube. So if there is no multiplicities, you add number of zeros, then you get the degree of polynomial. If the multiplicities are there, you add multiplicities. If there is no multiplicities, just add the zeros. Here 1 plus 1 plus 1, 3. So for P1x, we added the zeros, that is 1, 2 and 3. The three zeros, therefore degree is 3. Now we will see graphs of polynomials, behavior at intercepts. Linear behavior, sign changes. Here there is a sign change here. Single zero, therefore only 1 0 is there, linear behavior. Now we will see quadratic behavior. Sign does not change. See here, sign does not change. Before or after, the value remains positive here. Now cubic behavior. Here sign changes. The multiplicity is odd here. The multiplicity is 3 there. Therefore it is not 1, it is 3. Therefore sign changes here. It is not quadratic because multiplicity is not 2, and because it is odd, sign changes here. Now we will see graphs of polynomials, end behavior. This is A0 is the leading term coefficient. If it is positive and the power is even degree, then x tends to infinity, f of x tends to plus infinity. X tends to minus infinity, again f of x tends to plus infinity. Therefore the curve will be upwards like this, upward curve. Therefore we call this A0 as stretch factor. A0 is called stretch factor. Now if A0 is positive and the degree is odd, then x tends to infinity, f of x is plus infinity, and when x tends to minus infinity, f of x tends to minus infinity. Therefore left hand side it is negative and right hand side it is positive. The graph will be like this, right? Left side low to right side high. And when A0 is less than 0, negative, For even degree of n, x tends to infinity, f of x is minus infinity. Again, x tends to minus infinity, f of x is minus infinity. Therefore, it is a downward curve like this, right? And it is also symmetric about the y-axis. Please note, even degree means symmetric about the y-axis. Odd degree means it will be symmetric about the origin. We will see that when a0 is negative, for odd degree, x tends to infinity, f of x tends to be minus infinity. When x tends to minus infinity, f of x tends to plus infinity. Therefore, the curve will be like this, upwards on the left hand side to downwards on the right hand side. And this one is symmetric about the origin, right? And now here a0 is positive, here a0 is negative, because downwards a0 is negative, here upwards a0 is positive, and both are symmetric about the y-axis, therefore even degree. And here odd degree, because it is not symmetric about y-axis. And then here a0 is negative and here a0 is positive. From the right hand side characteristics, I decide about the sign of the coefficient. Now we will try to find out the solution for this problem. What is the characteristics of the leading coefficient? Since it is symmetric about y-axis, the degree is even. So n is even. And it is going upward, therefore a0 is positive. Therefore, a0 is greater than 0 and even degree, option 1 is the correct answer. We will see the next problem. Now here, it is even degree because it is symmetric about y-axis and it is going downwards, therefore a0 is negative. Therefore, option 4, a0 is less than 0 and even degree is the correct answer. This is the next problem. This is odd function and the sign of a0 is given by the right hand side direction, which is negative. Therefore, a0 is less than 0 and odd degree, therefore option 3 is the correct answer. And then here a0 is positive because right hand side it is going upwards and it is an odd degree because it is symmetrical about the origin. Right? We will see option 2, a0 is greater than 0, odd degree. That is the correct answer. Now we will see turning points. A turning point of a polynomial is a point where the gradient changes from positive to negative or negative to positive. See, it is negative and positive. At turning point, the graph of polynomial changes from sloping downwards to upwards or upwards to downwards. It is vice versa. So upwards and downwards and upwards. A polynomial of degree n can have up to n minus 1 turning points. So this is a third order equation. This is a second order equation. A quadratic can have only one turning point because degree is 2. Right? 2 minus 1 is 1. A cubic can have up to 2 turning points. No cubic can have more than 2 turning points because third degree, 3 minus 1 is 2. Therefore, these are all the curves. A quartic can have up to 3 turning points because degree is 4. So 1, 2, 3 turning points are there. Find the maximum number of turning points in the polynomial function. F of x is equal to 1 plus x squared plus 4x power 5. N is equal to 5 here. Therefore, n minus 1 is equal to 4. Maximum 4 turning points are allowed. This is the curve having less than 4. Find the maximum number of turning points in the polynomial function. F of x is equal to x plus 2 into x minus 1 whole squared. Here n is equal to 3, degree is 3, x into x squared. So n minus 1 is 2, 2 turning points will be there. At x is equal to 1, 0 has multiplicity 2. Please note, at x is equal to 1, it has. Now we will see graph of polynomials, polynomial creation. There are two ways. One is tabular form. You find out the values x and y and plot it. The another one is create from the graph. Right? Find x and y intercepts if possible. It may not have real roots, hence if possible I have written. Right? Sometimes x intercepts may not be possible. Check for the symmetry. If f of minus x is equal to f of x, the function is even and symmetrical about the y-axis. If f of minus x is equal to minus f of x, the function is odd and symmetrical about the origin. This we have seen it now in the previous slides itself. Use multiplicities of zeros to determine the behavior of the polynomial at x-intercepts as linear or quadratic. Multiplicity is equal to 2 means quadratic behavior. Multiplicity is equal to 1 means linear behavior. Sum of all the multiplicities of all zeros cannot exceed the degree of the polynomial. That is the degree of the polynomial. You add all the multiplicities, you get the degree of the polynomial. Determine the end behavior by examining the leading term. Refer the table given for this purpose. No, I've already given, we have discussed in detail. Using the end behavior and behavior at x-intercepts and sketch the graph. That's the final. You need to know calculus to know the exact location of turning points. But we can find out, no, obviously from the graph here. Ensure the number of turning points does not exceed 1 less than the degree of the polynomial. Check the Excel software and plot the graph mathematically using a software, using Excel. Sketch a graph of f of x is equal to minus of x plus 2 whole squared into x minus 5. We will see, we will try to plot this. X-intercepts, that is zeros, are x is equal to minus 2 and x is equal to 5. And again x is equal to minus 2 because x plus 2 whole squared. Therefore, minus 2 has multiplicity of 2, hence the quadratic behavior at minus 2. X has multiplicity 1 at x is equal to 5, hence linear at x is equal to 5. Therefore, at x is equal to 5, it is linear, at x is equal to minus 2, it is quadratic. Therefore, I have plotted. Now I have to find out the y-intercept. Is this correct? Right. To get more precise graph, find the y-intercepts. When x is equal to 0, it is 2 squared into 5, that is 20, plus 20. Therefore, I have to plot this at 20, not 50. It is 40, no? 30, 20. It should be going like this. And end behavior, it is going upwards like this and downwards like this. We'll have to check up. So, A is negative and the degree is odd. So, A is negative and the degree is odd means this is like this, right? Towards the right, it should go down. So, degree is odd. Where x tends to minus infinity, f of x tends to infinity. When x tends to plus infinity, f of x tends to minus infinity. And that is what we have shown in the graph. Right? Therefore, we can plot this graph as it is. Only thing is, minor modification is, you should not go through 40, you should go through 20. F can have at most 2 turning points. Yes, it has got at most 2 turning points. Right? Stretch factor is unknown A value. A value is obtained here. A is negative and degree is odd. And here minus 1. Even degree polynomial, therefore multiplicity is 2. Right? So multiplicity is 2 here. Even degree polynomial, only I am taking this x plus 2 whole squared. I am not considering the entire thing. Then degree is 3. For each term, find the polynomial. Here it is the polynomial of 2. Therefore, multiplicity is 2 here. Okay. Intermediate value theorem is very important. I will tell you what it is and then we will close this polynomials. If f of a and f of b have opposite signs, then there exists at least one value c between a and b for which f of c is equal to 0. There is a root. There is a 0. See here, this is, here fa is positive, fb is negative. Therefore, there must be a 0 value between these two. F of c is equal to 0 here. C is the in-between value. This is valid for all continuous functions and it helps to identify the roots of a polynomial. Is there a root in between these two values a and b? We can find out. And accordingly plot the graph also. That completes the session. Thank you very much.